Hello and welcome to another grade 10 mini lecture. Today we're going to be talking a little bit about atoms. It's really hard to imagine a topic in chemistry that's more important than the atom. Indeed, we should never trust an atom because they make up everything. I hope by the end of this lecture you'll be able to understand the joke in this meme here. So, atoms, what do they look like? What's inside of them? Well, I wonder if you've seen any of these pictures before. Take a look. Maybe you've seen this first picture, or this second picture, or this third picture. All of these are different ways people have to represent an atom. None of these are exactly what the atom looks like. It's actually really hard to know what an atom looks like. But these are ways that people have found to model or represent an atom so that we can talk about them, so that we can have a common language around atoms. I want to draw your attention here to the three parts of an atom. Atoms have protons and neutrons. Protons and neutrons are found inside the nucleus. Atoms also have electrons found outside of the nucleus. And again, none of these pictures is exactly correct in terms of what an atom looks like, but all of them are useful in order to demonstrate the parts of an atom that do really exist. So, this picture here, number 3, is probably the most accurate for what a real atom would look like with a nucleus surrounded by lots of electrons, but it is sometimes convenient to draw an atom like number 2 or maybe even number 1 to visualize the different parts that are going on. So what are atoms exactly? Take a look around you. Maybe you're in your bedroom and you see your bed. Maybe you're sitting on a chair. Maybe you have a glass of water next to you. Take a look even at your hand and the pen that you're holding. Everything that you can see, and even what you can't see, even the air around you, is made up of atoms. Atoms are the basic building blocks of matter that make up everything except for energy. A desk, the air, even you are made up of atoms. There's different varieties or types or kinds of atoms. About 90 of them occur naturally in the world, and scientists have made about 25 more types or varieties. Maybe you've already realized when we say kinds of atoms or varieties, we are indeed referring to elements. So elements are shown in the periodic table of the elements. This is a table that displays all of the known elements in the world, including the ones that humans have made. The ones that humans have made we find down here at the bottom. The areas of the periodic table we'll be focusing on are these areas that I'm circling in purple. This area here in the middle, called the transition metals, we don't really deal with. Let's take a look at particles now. So remembering back to last unit, we talked a lot about particles, and I'm sure you're wondering, how do those particles that we discussed before relate with what we're doing now with atoms? Well, particles, these were either atoms or groups of atoms. So before we used kind of a general word to get at this idea because we weren't ready to really study the atom in depth. But now you can see that when we said particles, we meant either a group of atoms, like with water, that has a hydrogen atom, an oxygen atom, and another hydrogen atom. Or we meant really individual atoms. Like you see here in this helium balloon, we have individual helium atoms floating around in this balloon. So the information we're learning here is not new or different. It's just a little bit more in depth to something we already saw, to the particles that we actually already saw. So, thinking about that periodic table that we saw and elements and atoms, I'm wondering what information can we find in the periodic table that might be helpful to us? Well, we can find the element symbol right there in the middle, and all periodic tables should have the element symbol. The element symbol is always that element symbol. So if you have a periodic table in Spanish or Italian or French or German or whatever other language, this helium, this He, will always be He. You'll also often have the chemical name shown. The chemical name is obviously dependent on the language, so this is a periodic table in English, so it says helium. Another language would have the word for helium in that language. We have the atomic mass. This is going to be an average mass for all of the atoms of helium, and different heliums can actually have a different mass. So the atomic mass, it's not the mass of one individual atom, it's actually an average mass for all of the heliums that exist in the world. And we also have the atomic number. The atomic number relates really directly to one of those parts of the atom we talked about before. Remember, there are three main parts to an atom. Do you remember what they are? Protons, neutrons, and electrons. The atomic number relates really specifically to the number of protons. So if I see an atomic number of 2, I know that I'm going to have 2 protons in my atom. Looking a little bit more in depth at protons, I think of protons kind of like a name tag. The number of protons is always equal to the atomic number. You'll notice there's also neutrons, there's also electrons inside of an atom. The numbers of those can vary, but it's the number of protons that tells me which element I have. So if I have 6 protons, I know that I'm carbon, because if we take a look at the periodic table, I have an atomic number of 6. So if there's 6 here, any atom, that has 6 protons will be carbon, no matter what. Any atom with 6 protons will be carbon. Even if there were a different number of neutrons or a different number of electrons, as long as there's 6 protons, I am carbon. So the number of protons was kind of like a name tag to tell me which element I actually am. We're going to do an activity next week in which we look at neutrons and electrons varying a little bit, so don't worry too much about those. For right now, I really want you to recognize that protons match up directly with the atomic number, this number that we find in the periodic table. I'll highlight it here for the first 2 periods or rows. So for example, if I have an atom with 1 proton, no matter how many neutrons and electrons, 1 proton will be hydrogen. If I have an atom with 4 protons, no matter how many neutrons and electrons, 4-proton atom is beryllium. If I have an atom with 10 protons, no matter how many neutrons and electrons, a 10-proton atom is neon. So, important for you to know right now are that there are 3 parts of an atom: protons, neutrons, and electrons, and that the protons match up explicitly with the number in the periodic table, with the atomic number. And that's always going to be the case. And the atomic number is always equal to the number of protons. Excellent job. Thank you for watching this video. You'll want to submit your notes for the video in Google Classroom, and be prepared because we will have a Google Form check-in and check for understanding at the beginning of next class. Thank you. Have a good day.